This series of videos will cover all of the features in Kontakt. We'll continue with automation and modulation. Never miss a tutorial by subscribing to our YouTube channel at youtube.com/ADSR toots. Whenever you need to control a parameter of an instrument from outside Kontakt using your DAW's automation or your MIDI controller, you can easily pick and assign appropriate automation sources from the Auto tab of the browser. At the top of the Auto tab, two buttons allow you to switch between a list of automation sources that are provided by your host and MIDI controllers. Assigning a source to parameter works the same way in both lists. Simply select a source from the list and drag it onto a knob whose parameter you want to automate. At the top of the Auto tab, two buttons allow you to switch between a list of automation sources that are provided by your host and MIDI controllers. Assigning a source to a parameter works the same way in both lists. Simply select a source from the list and drag it onto a knob whose parameter you want to automate. If you want to assign a knob or a fader of a MIDI controller, but you aren't sure which controller number is the right one, simply move the fader when the MIDI automation list is visible, and Kontakt will flash a red lightning bolt icon next to the respective list entry when it receives MIDI controller data. This allows you to quickly spot and assign the appropriate controller. Multiple parameters can be assigned to the same automation source. This allows you to control multiple aspects of your instrument with a single controller. Also note that modulation wheels usually send MIDI controller number 1 and volume controls send number 7. You can edit assignments and parameters by selecting them in a list. If the selected item is assigned to one or more parameters, these will show up in the list below. At the bottom of the pane, you can adjust some parameters of the assignment that's selected in the lower list. From percentage to percentage. By default, automation controllers are mapped in a way that makes them cover the whole available range of the assigned parameter. By changing these parameters, you can alter the scaling of the assignment so that the automation values are mapped to a limited range of the assigned parameter. A side effect of this is that this small slice of the parameters range can be automated with finer resolution. Soft takeover. This function avoids sudden parameter jumps that can happen if received automation data is different from the current value of the assigned parameter. If you activate this button, the assigned parameter will not be changed until an automation value is received that matches the parameter's current value. And remove. This button deletes the automation assignment that's selected in the lower list. If you can't assign MIDI controllers this way, there's an alternative method. In Browser Auto MIDI Automation, if you turn a knob or move a slider on your hardware controller, you should see a flash next to the CC number that's used by your external controller. Also, the MIDI symbol in the instrument header should flash. And finally, just drag and drop the MIDI CC number you want to use on the control you wish to control, as you saw earlier. And last but not least, you can also right-click on a control and click Learn MIDI CC Automation. Modulation. Kontakt's internal modulation system offers a powerful way to animate parameters, making them change over time in different and extremely adjustable ways. For this purpose, most of Kontakt's modules provide a table called the modulation router, which allows you to assign various sources of modulation signals to that respective module's parameters. Modulation sources. Kontakt's library of modulation sources is divided into 4 categories. Envelopes are finely adjustable curves of varying shapes, which have beginning and ends. These are usually used for creating non-repetitive parameter changes that can't easily be obtained from a traditional periodic waveform. LFOs, or low frequency oscillators are sources that generate a periodic waveform within a frequency range of 0.01 hertz up to about 210 hertz. In addition to the traditional set of waveforms found in synthesizers, sine, triangle, rectangle, sawtooth, and random, Kontakt also has a complex LFO, which generates a mixture of other waveforms. Others include sources that don't fit into one of the other categories, such as step sequencer or envelope followers. And last but not least, external sources, which provide access to control signals that are generated outside of Kontakt's modulation source modules, such as incoming MIDI data or constant or random values. Modulation destinations. Modulation routers can be found on most modules that work on a per group basis. This includes the source and the amplifier modules, as well as signal processing modules in the group insert effects chain. Also, modulation source generators using existing assignments can have their own parameters modulated as well, which makes for a multitude of crazy and complex possibilities. Modules outside the group level, such as instrument inserts or send effects, do not support parameter modulation. And the same way you can use one modulation source to modulate multiple parameters, you can also combine multiple sources to modulate one parameter. If you create multiple assignments with the same destination parameter, the modulation signals will be mixed together. Keep in mind, though, that a lot of modulation signals are bipolar and thus can cancel each other out as well as accumulate their values. Each modulation assignment that actively affects a specific parameter at any given time will be displayed with a single row in the modulation router of the parameter's parent module. The modulation router can be shown and hidden by clicking on the button labeled Mod in the lower left corner of a module. If this button does not exist, the respective module's parameters can't be modulated. If a modulation router uses an internal modulation source for the assignment, you'll find a corresponding modulation source panel at the bottom of the rack in the instrument edit mode. From here, you can adjust the parameters of the signal source, such as LFO frequencies or envelope timings. You don't need to scroll up and down and make adjustments to a modulation source and its modulation router entry. You can click one of the quick jump buttons on both panels. This will instantly bring you to the respective other panel. You can add a new entry to the modulation router, which creates a new modulation assignment in 3 different ways. Right-click on a knob of the parameter that you want to modulate, then choose a modulation source from the drop-down menu. The submenu at the bottom of this menu contains modulation sources which already exist in your instrument and allows you to assign an existing source to more than one parameter. If the module's modulation router is not currently visible, adding a new assignment will show it. This allows you to make immediate adjustments to the assignment parameters. The second way is in the browser to select the Modules tab, then switch to the Modulators category. Choose a modulation source type from one of the 4 lists. Then drag it onto a knob whose parameter you'd like to modulate. If the respective parameter can't be modulated, the mouse pointer won't display a plus icon. This method does not allow you to reuse existing modulation sources. And the third method is to open the modulation router of a module and click the Add Modulator button on the left side of the last row. This will open the same drop-down menu of modulation sources that you'll get when you right-click a knob. Since you can't specify a destination parameter this way, you'll have to change the modulated parameter via the drop-down menu on the right side of the new assignment entry. Deleting modulation assignments. To get rid of a modulation assignment entirely, select this entry in the modulation router by clicking on the panel and then press the delete key on your keyboard. If the assignment was using an internal signal source and no other assignments in your instrument are using the same source, the corresponding source panel will disappear from the modulation section of the rack as well. Assignment controls. As mentioned, all controls which affect the behavior of a modulation source can be found on the respective source panel at the bottom of the rack. There are additional parameters that affect in which way the source module's output signal will be mapped to the parameter to which it's been assigned. Since the source can be used to modulate multiple parameters in different ways, it doesn't make much sense to include these controls on the panel of the source. Instead, they are part of each assignment entry in the modulation router table. The controls on each assignment entry are modulation source. If the entry belongs to an internal source assignment, this value can't be modified, but external source assignments will offer a drop-down menu here that allows you to switch to a different source. The quick jump button, which is only visible on internal source assignments. If you click this, the button will immediately scroll down to the respective source control panel at the bottom of the rack. Once you're finished with your adjustments down here, the identical button on the panel will bring you back to where you came from. MIDI CC number. This is only visible if the source is MIDI CC. The modulation will acquire its value from incoming MIDI controller data with the number specified here. The modulation wheel usually sends MIDI CC number 1. Volume and expression pedals usually send MIDI CC number 7 and number 11, respectively. MIDI CC default value. Again, this is only visible if the source is MIDI CC. As the MIDI's controller current position can't be queried remotely and is thus unknown until actual data is received, this value can be used as a substitute until the first MIDI CC data is seen. A value of -1 in this field tells Kontakt not to modulate the parameter at all until actual data is received. The modulation shaper. If you need more control about the relationship between modulation signals and parameter changes than what's provided by the intensity fader, clicking on this button will open up the shaper table. This allows you to create all sorts of custom shapes from nonlinear transfer curves all the way to complex tables that assign each possible input value to a different output value. The active button in the upper left corner of this view activates the shaping of the modulation signal. When switched on, the window next to it will show a graphical representation of the table that's made up of 128 vertical bars, with each bar's height representing the actual value that will be used for modulation, if the value that corresponds to this bar is received from the source module. It's basically a transfer curve where the x-axis represents the input value and the y-axis represents the output value. By clicking and dragging a single bar, drawing shapes across bars, or drawing lines by right-clicking and dragging the mouse, you can quickly create your own shapes. Holding the Shift key while changing the height of a bar allows for finer editing, and Control or Command clicking on bars will reset them to 0. Table data can be imported and exported as a text file. To open the export dialog, Shift-click the active button. To open the import dialog, use Shift-Control or Shift-Command. Because nonlinear curves and other shapes can't be easily drawn with accuracy, the modulation shaper has an alternate editing mode, which can be accessed by clicking the table button in the lower left corner. In this mode, you can define your mapping using curve segments. This editor works just like the flexible editor. You can drag the endpoints of a curve segment to move them. You can drag the circles in the middle of a segment to change the curve shape. You can right-click or control-click on an endpoint to delete it, and right-click or control-click somewhere else to create a new segment. There are also presets that you can use and save as your own. The invert button. If this button is activated, all modulation will be reversed in one direction. So for example, a rise in the modulation signal will result in the proportional drop in a parameter value. Modulation intensity. This fader controls how large the parameter changes caused by the modulation signal changes will be. This is basically how far the assignment will cause the parameter to stray from its original value. As different modulation intensities can produce considerably different effects, this is definitely the most important parameter of the assignment. Smoothing. If this value is higher than 0, any signal received from the modulation source will be smoothed. The displayed value is a time constant in milliseconds and indicates how long the smooth signal would take to reach the new value after an instant change in the modulation signal occurred. The best use for this feature is a gentle smoothing of external MIDI data. MIDI has a resolution of 128 steps per controller data. If you use it without smoothing, it can cause audible parameter jumps. A low smoothing value will get rid of these while still keeping a fast response to controller changes. And finally, modulation target. The rightmost element displays the parameter that will be modulated. If you click the field, a drop-down list of all parameters that can be modulated in this module will appear, and you can choose a new target. Now that you know how to create assignments that connect a modulation source to a parameter, let's look at the various modulation sources that Kontakt has to offer. Kontakt offers 3 kinds of envelope shapes, each with one different set of controls. ADSR. This is Kontakt's take on the most common envelope type out there, the ADSR envelope, which is named after its parameters attack time, decay time, sustain level, and release time. With these 4 parameters, ADSR envelopes can create a surprisingly large number of different modulation shapes, which are well suited to simulate the natural dynamic behaviors of acoustic instruments. Kontakt's version of this envelope provides an additional hold time control. AHD only. If this button is activated, the envelope will be reduced to its attack, hold, and decay phases. This eliminates the sustain parameter, so what you'll get is a single, one-shot envelope, which will always be completed no matter how long the key is being held. This is best suited for drums and percussion sounds. Retrigger. If this button is activated, the envelope will be restarted every time Kontakt receives a note, even if another note is still being held at the same time. If it's inactive, the envelope will keep its current position until the last note has been released and then be restarted on the next note. Curve. This adjusts the curve shape of the attack phase. A value of 0 results in a linear attack curve, and negative values make the shape more concave. Positive values will make it more convex. Attack. This is the initial time it will take the envelope to reach its maximum level after it has been triggered. Hold. This is the fixed time the envelope will stay at its maximum level after it's completed the attack phase and before it enters the decay phase. Decay. This is the time it will take the envelope to fall from its maximum level to the level set by the sustain control. Sustain. After the envelope has completed its attack, hold, and decay phases, The envelope will stay at this level as long as the key is being held. And release. This is the time it takes the envelope to fall from a sustained level back to 0 after the key has been released. DBD. This is a rather simple one-shot envelope that rises or falls from 0 to an adjustable breakpoint above or below, then returns to 0. It works well for simulating things that happen during the initial attack phase of sounds. Retrigger. If this button is activated, the envelope will be restarted every time Kontakt receives a note, even if another note is still being held at the same time. Decay 1. This is the time it will take the envelope to rise or fall from 0 to the breakpoint after it has been triggered. Break. This is the level of the breakpoint. If the value is negative, the envelope will fall, then rise, and behave the other way around if it's positive. Decay 2. This is the time it will take the envelope to rise or fall back to 0 after it has reached the endpoint. Flexible envelope. This powerful envelope type allows you to create arbitrary modulation shapes by defining up to 32 breakpoints, each at a defined level and point in time. When you create a new flexible envelope, you'll initially see a shape which resembles a traditional ADSR envelope in this panel. Any changes to the shape of the envelope will take place within its graphical representation. Just like within other envelope editors, the x-axis represents the time, while the y-axis represents the modulation level. You can define an envelope shape by creating or deleting breakpoints, moving them around, and changing the shape of the curves that connect them. The initial preset is an envelope with 4 breakpoints. This is also the minimum number of breakpoints that have to be present in an envelope. In order to add a breakpoint to your envelope, right-click or control-click on the position where you want it to be created. Deleting breakpoints work in the same way. Right-clicking or control-clicking an existing breakpoint will delete it, causing its neighbors to be connected with a straight line. You can change these connections between breakpoints from straight lines to convex or concave curves by dragging the small circles in their middle, up or down. If your envelope is becoming longer than the time window that's currently being displayed in the editor, you can left-click and drag the timeline horizontally to scroll, or right-click and drag it to zoom in and out. You can move breakpoints around by dragging them with the mouse. The currently selected breakpoint will be indicated with a filled square icon. In addition to its graphical position in the editor, you can view its parameters as numerical values in the breakpoint status line above the editor. The values of the status bar from left to right tell you about the current positioning mode, the number of the currently selected breakpoint, its absolute position in time, displayed in milliseconds, its relative distance in time to the preceding breakpoint, its level, and the shape of the curve to the left of the breakpoint. A value of 0.5 indicates a linear shape, higher numbers indicating a convex shape, and lower numbers indicate a concave shape. You'll notice that when you move any point, except the last one horizontally, all points that follow it will move along by the same amount, thereby changing the overall duration of the envelope. If you don't want to do this, just click the mode entry of the breakpoint status line above the envelope editor. This will toggle the breakpoint positioning mode between slide, which is the default and shows the described behavior, and fix. Fixed allows independent positioning without affecting other breakpoints. In addition to the envelope shape, the editor displays 3 orange lines, 2 vertical and 1 horizontal, drawn in an H shape. The section between the vertical lines, which can be dragged to other breakpoints, except the first and the last point of the envelope, marks the envelope's sustain phase. This phase affects how the envelope will behave while a note is being held. What exactly will happen during this time depends on whether there are any additional breakpoints between the two orange lines. If the sustained part spans only the curve between the two breakpoints, with no other breakpoints in between, the envelope will freeze when it reaches the second point's level. This is indicated across the sustained part with the horizontal orange line, while the note is being held. In contrast, if there are any additional breakpoints between the start and end markers of the sustained phase, the whole section will be looped until the note is released, in which case the envelope immediately jumps to the section that follows the sustained phase. The first 8 breakpoints of a flexible envelope are special in that their positions in time and their levels can be modulated via external sources. To do this, open the envelope editor's modulation router and create modulation assignments in the usual way. Now that you know how the envelope editor works, let's have a look at the 2 remaining buttons of the panel. Retrigger. If this button is activated, the envelope will be restarted every time Kontakt receives a note, even if another note is still being held at the same time. Tempo sync. When activated, a vertical grid of note values will be drawn on top of the editor, the step size of which will depend on your current zoom factor. All breakpoints you move around in this mode will snap their positions in time to these grid lines, allowing you to create modulation curves in sync to your host or master editor tempo. Since this will make the actual length of your envelope change with the host tempo, the breakpoint timing values that were previously displayed in milliseconds will now be displayed in note divisions. Low frequency oscillators provide periodic, or in some cases random signals, which are typically used for modulation across all kinds of synthesizers and samplers. All of Kontakt's LFOs can generate frequencies within a range of 0.01 Hz to around 210 Hz. You'll notice that the upper part of this range actually overlaps the audio range, which opens up some rather interesting and creative modulation possibilities. But most of your traditional LFO assignments will most likely be between 0.01 Hz and 40 Hz. Once you've created an assignment that uses an LFO as its source, you can switch the waveform on this LFO's control panel in the modulation section of the rack. The displayed set of controls will follow your selection, so we'll only go over every control only once. I'll let you know if the control is specific to a waveform. The waveform button. This displays a waveform of this LFO's output signal and allows you to select a different one via a drop-down. The available waveforms are sine, triangle, rectangle, sawtooth, random, and multi, which is a mixture of all other waveforms. Retrigger. If this button is activated, the LFO waveform will be restarted at the same position each time a note is received. If it's inactive, the LFO will run in a freewheel fashion without reacting to notes. Frequency. This adjusts the frequency of this LFO's output signal in Hertz. Values range from 0.01 Hz to around 210 Hz. The LFO speed can be synchronized to your host tempo, an external MIDI clock, or your master editor tempo. To accomplish this, click the displayed unit of the frequency readout. A drop-down menu will appear allowing you to choose from a list of note values. After you selected a value, the LFO is in sync mode, and the frequency control will adjust and display how many notes of this value will make up the duration of one cycle. For instance, if you select whole and dial in the value of 1.0, an entire LFO cycle will span exactly 1 bar of a 4/4 measure. To return to unsynchronized mode, just select default from this drop-down menu. Fade in. If this value is greater than 0, the LFO will not start the waveform right away when a note is received, but rather smoothly ramp it up over time of up to 5 seconds. This works great on human-like vibratos. Like the frequency control, This parameter can be synchronized to a song tempo in the same way described earlier. Phase. This adjusts the position within a cycle at which the LFO will start its waveform when it's triggered. The value is displayed in degrees, with 0 being the start of the waveform, 180 the midpoint of the cycle, and 360 the start of the next cycle. Setting this parameter can only make sense when the retrigger button is activated. Pulse width is only on the rectangle waveform. This adjusts the duty cycle of the waveform. This determines the ratio between the high and low parts of the cycle. A pulse width of 50% results in a perfect square wave. The multi-waveform is special in that it's the result of an addition of other waveforms. Which waveforms will appear in this mixture and at which respective amounts can be adjusted with an additional set of controls which appear below the main row of knobs when you switch to the multi-waveform. Note that these mix controls are bipolar and thus allows you to reverse the polarity of source waveforms. At a value of 0.0, the respective waveform will be absent from the mixture. Normalize levels. Once again, this is only visible when multi-waveform is selected, but if this button is activated and the sum of all component waveforms in the current mixture would exceed the level of a simple waveform at its peak, the LFO will reduce its level accordingly. Other modulators include all internal modulation sources that won't fit into the other categories. The 32-step modulator works just like a classic step sequencer in that it allows you to freely define a row of up to 32 values, which will then be played back at a constant speed. You can define these bipolar values by drawing bars that originate from the middle line with your mouse. The higher a bar, the further the modulated parameter will stray from its original value at this point in the row. To draw a linear change across multiple bars, right-click or control-click and drag your mouse in the editor. This will draw a line which will be reproduced with bars when you release the mouse button. The speed at which a step modulator will move from bar to bar can be synchronized to your host or master editor tempo. Here's a look at the controls. Frequency adjusts the playback speed of the step modulator. Values range from 0.01 Hz to around 210 Hz. You can synchronize the speed to your host or master editor tempo by clicking on the displayed unit and choosing a note value from the drop-down menu. This is the number of steps. Click this field and drag your mouse up or down to change the number of steps in your row. As the modulator will immediately wrap to the first row after it has reached the end, a power of 2 in this field, like 8, 16, or 32, will ensure that the step modulator keeps aligned with a binary song meter during playback. Retrigger. If this button is activated, the step modulator will restart a sequence at the first bar each time a note is received. If it's inactive, the step modulator will run in a freewheel mode without reacting to notes. One shot. If this button is activated, the step modulator will play the row once, then stop. Otherwise, it will loop the row indefinitely. Tools. This opens a drop-down menu with 2 utility functions. Reset will set all step amplitudes to 0. Snap 1/12 will restrict all edits to a grid of 24 steps, 12 in each direction, which in combination with the pitch assignment with full modulation intensity allows you to create note sequences within a chromatic scale. Envelope follower. The envelope follower analyzes the amplitude of the currently played sample and generates a modulation signal from it, thereby replicating the dynamic envelope of the audio signal for your own use. In other words, whenever your audio signal gets louder, the modulation signal will rise accordingly. When it gets quieter, the modulation signal will fall. These are the available parameters. Attack adjusts the envelope follower's response time to rising levels. Larger values will smooth out the attack phases that correspond to increasing audio levels. Very short values can cause distortions, as the envelope follower will begin to track each cycle of the audio waveform. Decay adjusts the envelope follower's response time to falling levels. Larger values will smooth out the decay phases that correspond to decreasing audio levels. Very short values can cause distortions, as the envelope follower will begin to track each cycle of the audio waveform. Gain adjusts the envelope follower's sensitivity to the audio signal. Larger values result in a higher envelope amplitude. And adapt sets a baseline transient response time for the envelope follower. Glide. The glide module acts as a source for a special modulation signal that's needed to create a Portamento effect. This effect is known from monophonic synthesizers and adds a sliding transition between the pitches of two consecutive notes when they are played in a legato fashion. To create a Portamento, assign the glide module to the pitch of your source module and set the corresponding modulation intensity to the maximum value. Using this module in other ways rarely makes sense. Also note that while using this facility with a polyphonic instrument works, the effect is usually associated with monophonic instruments. The module provides two controls: time, speed. This selects one of two different glide modes. If time is selected, all transitions happen in the same time, regardless of the interval between the notes. In speed mode, wide space intervals will result in longer transitions than close space intervals, as the glide speed will be kept constant. Speed. This adjusts the speed of the Portamento. You can also synchronize this parameter to your host or master editor tempo by clicking on the displayed unit, then selecting a note value from the drop-down menu and adjusting the numerator for this value with the speed knob. External sources includes all modulation sources whose signals don't originate from one of Kontakt's source modules. Pitch bend. This kind of MIDI data is usually sent by pitch bend wheels or levers on MIDI controllers. Unlike normal MIDI controllers, pitch bend data is transmitted in a rather fine resolution of 14-bit, which provides 16,384 value steps. If both your controller and the parameter that you like to modulate can work with this resolution, Kontakt will use it to its full extent. Poly aftertouch. This controller, also referred to as key pressure, is sent by a rather small number of MIDI keyboards and allows you to receive aftertouch pressure data for individual keys. In order to create an instrument that responds to polyphonic aftertouch, you'll need to spread your voices across multiple groups that are cycled in a round-robin fashion, so that the pressure of each key can be processed within its own group. Mono aftertouch. This controller, which is also being referred to as channel pressure, provides a single value for the aftertouch pressure that's applied to held keys. It's sent by a wide range of MIDI keyboards. MIDI CC. The MIDI spec provides 128 continuous controllers, 0 through 127, for general use. These are supported by almost all MIDI controller devices and used for transmitting the status of controllers like modulation wheels, sustain, volume pedals, or general-purpose fader banks. Some controller numbers are assigned to standard devices: number 1 modulation wheel, number 7 volume, number 11 expression, and number 64 sustain pedal. But Kontakt doesn't take that into account. You can use all controller numbers between 0 and 127 as modulation sources. Key position. This source provides access to MIDI note number of a pressed key. It can be used to change parameters like a filter cutoff in response to the pitch of a played note in order to make keyboard tracking possible. Velocity. This is a value between 0 and 127 that indicates how hard a key has been hit. It's transmitted by almost all keyboards and is frequently being assigned to parameters like volume, brightness, or the length of an attack phase. Release velocity. This value is sent by a very small number of MIDI keyboards. It indicates how slow or fast a key is being released and is useful for changing the length of a sound's release phase accordingly. Release trigger counter. This value is generated for groups that are being triggered on a release and indicates the time between the trigger and the release signal. The external category also includes 3 special sources of scalar values that won't change over time. Constant will simply add or subtract the value of the modulation intensity fader to the modulated parameter. It can be used to easily bend parameter values beyond the range limits of their controls. Random unipolar will generate a random value between 0 and 1 for each received note. Random bipolar will generate a random value between -1 and 1 for each received note. Congratulations, ladies and gentlemen. We have now covered all of the features in Kontakt. You should now have a thorough understanding of how every single button and knob in Kontakt works. It was a long and grueling 15 weeks, but this basic understanding of how all the features in Kontakt work is necessary for the more intermediate and advanced concepts in the upcoming weeks. And don't forget to check out our website at www.kontakttutorials.com for more Kontakt tutorials and sounds. ADSR Kontakt tutorials. Supercharge your Kontakt skills. This is DJ Nice signing off until next time. Now go make some music.